at this screen. Dense blocks of text, overlapping videos, and a quiz popping up out of nowhere. How long would you stay on this page before closing the tab in frustration? Without a physical teacher to read body language or guide attention, remote learning environments leave students to navigate complex material entirely on their own. Uploading a 50-page PDF or a 2-hour lecture provides access to data, but leaves the burden of synthesis entirely on the learner. To bridge the gap between raw data and comprehension, educators use a systematic process called instructional design. Instructional design is the process of structuring content into deliberate activities that facilitate learning and keep students focused on the subject matter. In this environment, the designer acts as a representative for the student, ensuring that every module is built around the learner's capacity to process and retain information. Solving a navigation or engagement problem begins with Step 1, analysis. Designers examine the audience, the platform's technical requirements, and the specific expectations of the stakeholders. This data informs Step 2, identifying learning objectives. This requires defining exactly what a student must be able to do or explain by the end of the lesson. This flowchart shows how designers handle raw content. Information is sorted into 2 pathways, a prioritized must-know pipeline and a secondary good-to-know bin. As the secondary information fades away, the must-know content reorganizes to form a solid building foundation. Strictly prioritizing objectives prevents cognitive overload. By removing the non-essential details, designers ensure students can master the required skills without becoming overwhelmed. With the foundation set, we move to Step 3, develop design strategy. This is the high-level plan for how the subject is taught, whether through a story-based narrative or a problem-solving approach. While the content tells us the what, the strategy provides the how, acting as the game plan to make the objectives reachable. Next is Step 4, create a storyboard. This visual document organizes the strategy into a flowing sequence of topics, visuals, and audio cues before any final media is created. To test these ideas early, designers move to Step 5, develop a prototype. This is a functional, interactive sample of a single part of the course. A working prototype allows the team to see how the storyboard's logic translates into an interactive digital experience. This sequence acts as a fail-safe, ensuring the learning experience is effective before the organization invests in full-scale production. Once the plan is validated, the project enters Steps 6 and 7, develop and deliver training. This comparison shows the difference between the fields. Instructional design, the blueprint on the left, is the logic of the lesson. Instructional technology on the right refers to the software and media tools used to deliver that lesson. In Step 6, that technology is put to work. Developers record professional voiceovers and build the interactive knowledge checks specified in the storyboard. Step 7 is delivery. Finished files are uploaded to a learning management system, or LMS, where the organization can host and track the training. Even the most advanced media tools cannot fix a lesson that lacks a clear instructional plan. The technology only works if the design underneath it is sound. The final step is Step 8, evaluate impact. This is how designers determine if the training actually worked. If a course is designed to teach a specific manual skill, like operating machinery, does a standard multiple-choice quiz prove the student can perform the task safely on the job? Post-course evaluation confirms whether the module altered learner behavior and met the objectives established at the start of the process. Notice the difference in this interface. By using clear navigation and focused visuals, we remove the friction that caused the frustration we saw earlier. This clarity is the result of a principle called congruence. This triangle represents congruence, the direct, stable alignment between the objectives, the learning activities, and the assessment. If these elements fall out of alignment, for example, if the assessment asks questions about topics the activities never covered, the educational experience breaks down. Following a systematic design process ensures that these elements stay connected, resulting in training that is efficient for the developer and appealing to the learner. By prioritizing the student's cognitive limits and aligning every activity with a specific goal, instructional design replaces the overwhelming information dump with a repeatable framework for skill mastery.